And welcome, guys, back with another Usaco walkthrough here. Today we're going to be tackling the Usaco 2018 February contest. We're going to be tackling the second problem called Hoofball, and let's jump right in. Alright, so let's start reading. So, in preparation for the upcoming Hoofball tournament, Farmer John is drilling his N cows numbered 1 to N, where N is between 1 and 100, and passing the ball. The cows are all standing along a very long line on one side of the barn, with cow I standing XI units away from the barn. So XI is simply just a variable. Each cow is standing at a distinct location. At the beginning of the drill, Farmer John will pass several balls to different cows. When cow I receives the ball, either from Farmer John or from another one, she will pass the ball to the cow nearest her, and if multiple cows are the same distance from her, she will pass the ball to the cow farthest to the left among these. So that all cows get a little bit of So that all cows get at least a little bit of practice passing, Farmer John wants to make sure that every cow will hold the ball at least once. Help him figure out the minimum amount of balls he needs to distribute initially to ensure this can happen, assuming he hands the balls to an appropriate initial set of cows. Alright, so he's just gonna pass some. We just need to calculate the minimum amount of balls that Farmer John needs in order for all of the cows to hold at least one. So the input format is simply just n and basically a list of n length, where the ith integer is xi. So basically these all are marked distances from the barn. Please output the minimum amount of balls Farmer John must initially pass to the cows, so that every cow can hold the ball at least once. So in this case, there's 5 cows, and these show the distances are that they're away from the barn. So, for example, 7, that means this one's 7 units away from the barn, 1 unit, so forth. So they didn't take the effort to actually sort this. So our first step would be to sort this array to essentially organize it. So if we take a look at this example, Farmer John should pass the ball to a cow at x1, basically right here, and pass the ball to x11. So he's going to pass to opposite ends of the cows in this situation. If you don't know what I mean, 1 is basically the minimum and 11 is the maximum. The cow at x1 will pass her ball to x3. So as you know, the cow will pass their ball to the closest cow to them. So in this case, 3 minus 1 is 2, and that's the closest one to 1 right now. So it's going to pass it to x3, after which this ball will oscillate between the cow at x3 and x4. Essentially, when the ball is at x3, it's going to pass it to x4, but then x4, since the next one would be 7, x3 is closer to 4 than it is to 7. So in this case, it's going to toggle between 3 and 4. It's going to pass each other, and it's not going to move anymore. Now we've fulfilled, in this case, 1, 3, and 4. Now we still have 7-11 to basically fill with balls. The cow at x11 will pass her ball to the cow at x7, who will pass the ball to the cow at x4, after which this ball will also cycle between the cow at x3 and the cow at x4. So in this case, we covered 1, 3, 4. Now all we need to do is pass 1 to 11. He's going to pass it to 7. And now all of our cows have held the ball at least once. Alright, so I've prepared basically a slide deck, basically organizing a single method that I thought of in order to solve this problem. So first we got to sort the array. As if we look here, basically these distances are mixed up and they're completely basically unorganized. See, 7 is first, that's not really organized at all, and then you got 11 here. Yeah, it's just not organized at all. So first we sort it, and then so basically, if let's just say this length is 2 or less, and then obviously the answer is going to be 1. As if Farmer John passes the ball to a cow with length, and there's only one other cow it's obviously going to pass that ball to the other cow. So, for example, pasting in the test case, this is for sorting. Basically, if let's just say we have 7, 1, 3, 11, 4, and then we sort it to 1, 3, 4, 7, 11. So, and this is where we get into more algorithm stuff here. So essentially, we need an array to calculate basically what direction the ball is going, and we're going to use those directions to calculate the amount of balls we're going to need. So we create a Boolean array of length n in order to store whether to go right or not. Basically, right is true and false is left, and then calculate the amount of balls based on that array. So we put true if the left distance is greater than the right distance, in which we check with a simple if statement. Oh yeah, so sorry. Basically, if the left distance is greater than the right distance, oh sorry. Yeah, so we put true if the left distance is greater than the right distance, basically saying that the right distance is shorter than the left distance, so we pass the ball right, and if not, we put false and we pass the ball left. So in this case, if we look at this one, 1 goes to 3, that's still going right, so it's true, and 3 goes to 4, it's also true, but then it goes back to 3, so in that case, that's false. And then if we look at 7 here, that 7 also goes to 4, so it's also false. And 11, it can't go anywhere else, so it also is false. So now we just established a basic algorithm that we're going to use to calculate the amount of balls using a Boolean array. So calculating the number of balls. So in this case, we have true, true, false, false, false from the example input they give us. Basically, 7, 1, 3, 11, 4. From our array, we start from the left and look for a streak of multiple T's followed by multiple F's, and we restart if there is a new T after reading an F's. So essentially, if there is if there's an F after a T, that means the ball will oscillate. So in that case, we can calculate how many balls we need if there is a streak of T's and F's. So in this case, we get, if we look at this example array here, basically we restart if there's a new T after reading F. So in this case, we got one streak. So essentially, we're saying that if we have trues and then falses in one order, then we can count that as a streak. However, if let's just say there's another T here, oops, sorry about that, another F here, we would have to restart our streak as it won't oscillate anymore. So for each streak, we count the number of T's and F's and compare them with 1. So we're doing this because if we have to compare them with 1, because if both are greater than 1, then we need 2 balls to pass from both ends to cover all the cows. Basically, it's the same logic in this problem. If they're both greater than 1, that means they'll oscillate within one number, and therefore we need more than one ball to allow all the cows to have equal sharing of each ball. So if either number is less than or equal to 1, then we only need one ball to cover them. And the reason why is because when we go right and left, that's not balanced. Basically, we go too much right or we go too much left, and it's going to cover more cows. For example, if we have TTF or TFFF, that would equal to 1, as we need both of them to be greater than 1. So let's just take 1, 100, 17, 20, 45, 18, and 52 as an example. So if we sort this real quick, we would get this order. Oops, sorry about that. And if we convert it, basically saying if we have 1, we have nowhere else but to go but 17, so that's still true. So 1 is true. 17, 18, that's 17, 18, that's a distance of 1, and that's less than 16, so we go right as well. So it's still true. And in this case, we get a false, as 18 to 20, that's 2, and 17 to 18, that's 1. So in this case, we'd have to put false, and then another false, as 20 is closer to 18 than it is to 45. Okay, now we have TTFF, or true, true, false, false. And if we look at 45, 45 to a distance of 20 would be 25, and to 52 it would be 7. So in this case, we're going back to true again. So in this case, TTFF would be one streak. And then if we continue with our array, we get 52 and 100. So that's 52 would also be false, and 100 would be obviously false, since it has nowhere to go. So one thing you'll notice is that the first one is always going to be true, as it only can go right. There's no value in front of it, and the last value always have to be false, as it can't really go right. It has to go left, so it has to be false. So if we count the number of streaks here, I kind of highlighted it in different colors to see better. TTFF, if you see here, is one streak, and TFF is another. So TFF, the amount of trues and falses are both greater than 1, so it would be 2. So we add 2 balls. So but however, if we have TFF, only one of them is greater than 1, the falses, and the other is equal to 1. So in this case, it will be 2 plus 1, which would be 3. So I created this little chart here that allows us to essentially calculate based on this array. It allows us to calculate the different. So in this array, it has 7 elements. So I created a chart to basically model our variables and our looping throughout the array. So we always need to check whether the first so we need to check both of these values. So that's how we're going to check whether this one is greater than it, or this one is a closer distance. These two are closer distance together, or these two are closer distance together. Basically, we need to use previous numbers to calculate essentially whether to go right or left. So now we can start coding. Alright, so let's just open up our IDE real quick. In this case, I'm using IntelliJ again. And we're just I opened a new file here called Hoofball. That's what the problem is called, if you would. Like, for example, here, the input and output files are called Hoofball. That's generally how I organize my files. So, I have the file called Hoofball here. It's basically just creating a new file from the source file by right-clicking this and pressing New, press Java class, and you'll name it Hoofball. And right here we have our standard buffer reader and print writer. So this is going to read our input real quick. So let's just speed run through reading in the input, and as it's not really that important. So the first piece of input that we're going to take in is basically going to be this integer called n, which is going to be the length of, or basically the amount of cows in this array, if you would. So we're just going to take in the n integer, basically integer %, as it starts as a string, and then we need to convert it to an integer. Oops. br.readLine. Don't forget the L is capital. And now we have to read an array. So let's just create a variable for that. Let's just say array equals new int, and of course it's going to be of length n. And let's keep going. So we're going to declare a string tokenizer. We only have to declare 1, as we're only reading in 1 line. So I'm just going to call it st for simplicity. And that equals new string tokenizer and br.readLine. So basically it extends the br method. So now that we have that, we're going to use a for loop and read in all our input. So I equals 0, I is less than an n. You don't have to use I've been using I for my entire life coding. So now we're just going to redirect each of these inputs into the array. Remember to parse int as they start as strings, and st.next token. Oops. Okay, so now we have essentially basically just written the input and put it into an array. So now we can work on our method, basically how we're going to solve the problem from the array. Well, first I'm just going to declare a method. It seems to be easier for this problem. So let's just call it public static int solve. So it's an integer thing, as we're returning an integer, basically the amount of minimum balls. So, but we're going to take in an array. Okay. now we can just, oops, sorry about that. Gotta use brackets. Alright, so it just has a red underline as they're missing a return statement. So now we have a new method. We need to declare something for the length of it. So in this case, let's just do a lowercase n and call it int n equals vowels.length. Oh, sorry, array.length. So int n is just going to be basically the same thing as n. It's going to be something that we can use to loop through this array. So first off, like we said in our slides, if the length is 2 or less, we output 1 as only one ball is needed. So let's just do that real quick. So just put a quick if statement here. Say if n is less than 3, return 1. Okay, and now we can create that Boolean array, and let's just call it right, as it's true if we go right and it's false if we go left, and then we can call it a new Boolean. Sorry, pardon my pronunciation, real quick, if you would, and then semicolon, and then we say right 0 equals true. So it's, as we always know, that the first one is always going to be true, as there's no cow to pass to on the left. So right 0 equals true, and let's just start the if statement now. So in I equals 1, we're going to start at 1, not 0, as if you see here, you'll see that in this array, the first one is we already know is t, so we're just processing the second one after we start. So it's going to be n minus 1, I plus plus. If we don't put n minus 1, then we're going to get an index out of bounds exception. So we're going to say if array I. So this is just saying we go right if the left distance is greater than the right distance. So if array I minus array I minus 1 is greater than array I plus 1 minus array I. So if we just look over this logic real quick, so array I is just going to be the one we're on right now, and array I minus 1 is going to be the one to our left. That's why we have to start at 1, as there's no 1 to the left for the 0th element, or the first one. So in this case, if we start at 1, let's just bring up an example real quick. We're checking if, let's just say we start at 3, we're checking if 1 is closer to 3 or 4 is closer to 3. And in this case, we're going to do that and say if that is true, then right I equals true. So what we're doing here is that when we declare a new Boolean array, everything starts as false. And if we change those to true, we now have a complete array full of trues and falses, just like we have over here. TTFFF. Alright, now let's just continue on. And let's do this. So let's just put some comments real quick here. So comparing right and left distances, and now we just have to count them up. Count the amount of T's and F's within a streak. So let's just call Boolean prev equals true. So we always need to compare the previous Boolean and our current one, and then Boolean false, current equals false, and say our count equals 1. So our count is just going to be the counter for our right and left, and it's already 1, as we already know the first one is going to be 1. Left count equals 0. Loop through data count lifts within a streak, and then we're just going to loop through it equals 0, I less than n, I plus plus. So cur equals right I. So right now we're just setting the current value that we sweep through to be right I, or in this case, just an element in the Boolean array that we loop through, and then we continue on. And say if prev equals false and cur equals true, then in this case we're starting a new streak. So as you can see back into our slides, our streak is defined by trues and then falses in that order. However, if you have more trues after your initial false, you have to start a new streak, as that's going to decide how many balls we have by the counting amount of balls within each streak. So we're just going to say, let's just starting a new streak, and then we say, okay, so now we can add an if statement. Within our if statement, say if our count is 1 and left count is less than 1, then we just add 2 balls like we said earlier. Oops, gotta declare a variable for that. Alright, so actually I just created a variable to count up the minimum amount of balls called ret equals 0. You can count if you want. Basically what I wrote down is that basically if our count is both are greater than 1, as you can see again, ret plus equals 2, and else ret plus 1. Basically, if both of them are greater, if both the amount of trues and falses are both greater than 1, then we add 2 balls to account for all the cows in there, and else we just add 1 ball. Alright, so moving on, we need to update our count and left count. So after this, we need to say our count equals 0. Oops, sorry. And left count equals 0. Now we need to add some other statements to update our count and left count. So essentially, if cur equals true, and you put our count plus plus, and else, or the cur equals false, the left count is plus plus. So left count is basically false, and right count is going to be true. And now we have to set prev to cur, as we need to update every value that we loop through. Alright, now we're pretty much done with this part of the if statement. For loop. And now we just need to check whether now we need to check again whether our count. So basically, if we're checking our count and left count here, if it's the end of the streak, but we also need to check it every time. So in this case, we gotta do 1. Basically the same thing. I'm pretty sure we can just copy and paste it. So if we do that, and we just click on here. Oops. Alright, great. So the final thing would be to just simply return our output. So, oops. So let's look at the scope here. So just right here. Right. What is this? Oh. I'm missing. Alright, so that should work. So now we can bring in our test data real quick. That's from last time. And I'm just going to copy and paste this into our test area. And run it. seems to be another error. Yep, we still have a missing semicolon there. And now we can just test run it. Alright, so we didn't get any errors, and we look at the output. Oh yeah, sorry. Yeah, so after we finish our method, we need to actually just print it out. And beforehand, we actually have to sort the array. So in this case, it's and input the method, input the class, and then we use the method, and we print it out using PW. So if we just say, let's just do right here, PW dot print line solve array, and then close it, and it should work. Right, now you can see, and we get 0. So now we have to look for any possible errors, as I believe the answer is 2 instead of 0. Okay. So if we just look through our code over here, I can't really see any visible errors. Let's see. Alright, I'm just gonna look for the error, and I'll be back when I find it. Alright, guys, I'm back, and it seems like that I copy and pasted. Copying and pasting this part of this statement is relevant, so I can just do that, and I could quickly move these over here. This one. Alright, so oh yeah, this has to be within that. And yeah, now it should work. So if I do that. Oh, something wrong with our indenting here. Let's see here. Okay, so alright, I see. So seems like we have indenting error. We just need to add a bracket somewhere. Let's see. So probably where we leave the if statement over here. And what is this next to? Okay. There's that one. Oh, okay, so yeah, we don't even need this one. Alright, so now that we have fixed the indenting, we can just run it. And and we get 2. Alright, so now that we can run it, put it into the Usaco website, let's just change these to Hoofball, basically the ways that they should be. And now we can find the file. Mine is right here, I believe. Here, oops. January, Febron, source, Hoofball, and let's submit it and see what we can do. It's grading right now, and we got 4 test cases, 9 test cases, and finally 10 test cases. Alright, so we have our code, and we're passed all the test cases, so that means that we solved this problem. So thank you guys for watching. We just tackled the problem 2018 February contest, the problem 2 Hoofball. So please subscribe if you enjoyed, and smash that like button. Thank you for subscribing. Next time.